Good morning, all, and thank you, sir. Myself, Mr. Pavan Kulkarni, working in Grasim Industries Limited. Uh, I thank IPTA team for providing us an opportunity to share our digitalization journey in this pulp viscosity variation reduction through AI/ML model. So, our Harihar pulp is located in Karnataka. It is located in Karnataka, and we are producing 210 tons of dissolving grade pulp. So, our Harihar unit is started in 1972, and our mill operates with 100% eucalyptus wood. So, our raw material is eucalyptus wood, and we are following the two-stage cooking process. Our mill operates with ODL and 5 stages of bleaching sequences. In these 5 stages bleaching sequences, we are following D0, EOP, hypo, E2P, and D1 stage. So our pulp viscosity variation is taking place in the final stage. So we have to control this final stage variation. So we found to control this viscosity, we have to initiate the study in bleaching section. So here you can see our viscosity variation start from in bleaching section. So this viscosity variation will impacting our internal customer viscose department. So in their viscose in their in this viscose process, they are struggling with this ball fall variation and splinter counts. So in this current competitive business scenario, meeting our customer growing expectation and demand with old technology, it is a challenge for us. So we are procuring wood from unorganized sectors. So these wood impacting our final pulp viscosity. So as our speakers, Mr. Gautam sir explained earlier that our technology playing an important role. So this AI is working. So this AI is helping us to reduce our final pulp viscosity. So here our consistent quality of the final pulp, it is needed for our customers. So this in the day-to-day life. So to survive in this market, we have to give constant pulp supply, good quality pulp to our customer to satisfy them, and we have to reduce the customer complaints from them. So we have analyzed for this pulp variation, viscosity variation, around 80 parameters. So in that 80 parameters, we have brought down to 25 parameters which are impacting in our hypo stage bleaching section. So in this 25 parameters, we have brought down to 4 stages using this mini tab. So we have formed a team and in-house team, and we have developed a algorithm and hypo algorithm in July 2021. So our first algorithm is simple regression. In this simple regression, we have targeted hypo brightness and EOP brightness, and these last 3 hours hypo dosage. So here actually we are not getting up to the mark of hypo viscosity variation. So we are calculating viscosity variation in terms of coefficient of variation. So we have to brought it down. So here we fine tune to 10-point regression method. In that 10-point regression method, we have taken this actual EOP brightness included in this algorithm. So this algorithm still it will not improve our pulp in hypo stage. It will not improve our coefficient of variation. So further we have developed this 6-point regression method. in this 6-point regression method, we have taken this actual EOP viscosity and target hypoviscosity. So, and this sum of deviation from the last 3 hours hypodosage. So these whatever hypodosage we are giving from last 3 hours, we are calculating here. So this 6-point regression is also not taking much results for our coefficient of reduction in the final pulp. So again, we have fine-tuned to multivariate method. In this multivariate method, we have taken this hypoconcentration and pulp flow rate. So these learnings we have got from the from one model to one model. So we are including this hypoconcentration here in this multivariate method and our pulp flow rate. So this is somewhat promising our viscosity variation to control in the final stage. So further, we have developed this 5C and 5D model. Why? Because this multivariate method in the 5C model, sometimes this hypo dosage it is recommending to 0. So for that, we have to improve. We have improved in the 5D process so that the hypo dosage should not become 0 at the time of process run. So these are our some results. You can see here. So actually this pointer is not working actually. So here you can see this model number 1 to 4, we have reduced from 7 to 2% CV percentage in the final pulp viscosity. And in 5D model, we have taken bring back to average 2.8% CV in this 5D model. So these models were developed in the Excel sheet. And we are entering data from the lab results and lab results through SAP, and we are taking data from Pi historian data also. So these data are implementing in the Excel sheet through manual. So we are getting this hypo model and we are checking in the offline only initial stages. So in this initial offline stage, we found that this 5D model is somewhat compromising us, and it is further we have it is helpful us to further develop in artificial intelligence in AI/ML model. So in this AI/ML model, we have taken this AI/ML collaborative team and we form a team, and we have explained all the parameters of our pulp, and we have told them our process conditions, and we have developed the AI/ML model through all these data. So this AI/ML works on so this AI/ML works based on the last 2 hours EOP viscosity and hypoviscosity. So here you can see, so this EOP viscosity and this hypo addition from last 2 hours, it is taking and it is delivering hypo, what is the required hypo stage at that time. So this AI/ML model we have checked for 1 month in offline, and we have developed a trial. So this reduced our final pulp viscosity to 5% to 2%. So you can see here in hypo pulp stage, we have around 7% of CV in CP variation. It will bring back to 4% variation. So this CV percentage variation means this hypoviscosity variation has reduced, no, that will impacting our customer. So that impact and benefits our viscose process. How it will benefits us means to reduce the ball fall variation and to reduce our filtration delay. You can see here in machine number 3, we have reduced the splinter counts from 80 to 50, and in ball fall from 55 to 50 we have reduced. So to sustain this AI/ML model, we have entering manually earlier stage in Excel sheet. So we have taken this data from SAP and Pi historian data, and we have connected this data to our model, this AI/ML model. So it will take data from online, and it will predict the required hypo dosage. So here you can see the recommended hypo dosage is 50, and the actual process value it is going on 51. So this model will also shows the accuracy level. So here you can see, it will recommend 50. Hello. It will recommend 50 liters per minute of hypo, and the actual dosage is 51. So it will predict our AML model also, and how it will works. We can collect the data from this model, and we can save it in Excel and PDF also. So these data will help us this how this AIML model is working. So as I have told you, some key learnings we have taken it out. So we have developed a stage wise these models. So whenever we are these are some key learnings. This in hypo stage, the delta is very important role, and it is impacting our hypo stage viscosity. So as I have told you, the models which we have started from first model, it will provide us more insights. What are the variables impacting, like this hypo concentration, pulp flow rate, and EOP brightness, EOP viscosity? These all parameters are impacting our hypo viscosity. So we have come to know about this learnings from this model. So finally, this AML model applicability in process, which improves our product and process quality and cost optimization. So these are our results. We have deployed around 24 lakhs of capex for this model, and we have reduced our customer complaints viscose department from 14 numbers to 3 numbers. So earlier in FY20, we have getting around 14 numbers of complaints, and we have brought it down to 3 numbers in FY24. So this is much important to satisfy our customer and to available in market in always. So this will help us. So we are thinking to implement this hypo dosage online, but now we are online through means we want to connect this model to DCS directly, and we are further implementing this model in D0 and D1 brightness, D0 and D1 to control our brightness also. So thank you for all for listening our paper presentation.